Now let's move ahead and use the RDD to read the text file and then apply some operation on that particular RDD. I am going to use the Sophia air quality dataset that is present in Kaggle, and we are going to perform some of the operations of RDD to see how actually we can leverage RDD to perform the transformation and actions on the file that we can read from a particular location. So in this particular case, we are going to read the Sophia air quality dataset. It is a text file. It has multiple columns like row ID, sensor ID, location, similarly temperature, pressure and humidity. Now if I want to read the text file, I can use sc.textfile, and if I run this, it will actually read the text file in this particular RDD. And if I see the type, it will give me the type as pyspark.rdd.rdd. If I want to see the 5 rows as a sample, I can use take5 function, and you can now see over here that it looks something like this. You can see that we have header available in the dataset. So the first step would be to remove the header. So if I want to remove the header, I can apply the logic as I will first take the first element, that is the header. So I'll do the rdd.first. It will give me the header from the RDD, and I want to remove this header, so I can use the filter function that is available in the RDD. This filter function is going to remove the header, so it is going to compare this string with other string. Wherever there is an occurrence of this particular header, it will filter it out. So since there is only first occurrence, it will remove that particular occurrence of the header, and you can see that in the data set now we don't have the header available. Now if I want to count the number of rows, I can do rdd.count, and it will give me the count of the rows. Similarly, if I want to again sample it out with one element, you can use the rdd.take1. So we have 701k count of the records that is available in that file. Now if I want to perform any transformation, like I want to split the text file using the comma as a delimiter, since in the RDDs we don't have any structures, unlike data frames which is like a table, you have different options available. Like whenever you are going to read a text file of the CSV format, there is a function available in data frame, but in the case of RDD we don't have any such function available. So we have to do it at a more granular level. So we don't have the column name available, so we should know that what is the header of this particular RDD, and based on the header we can pick the elements instead of passing the column name, since we don't have any column name available in the RDD. Now I'll first split the elements like using the map function. In the map function we have row.split, like we have seen in the word count example, we are splitting the words. Similarly we can split it over here like this. So if I do a take one, you can see that we have a list of the records. So each column is represented by a different element in the list. Similarly there would be a list created for each of the records in the RDD. So if I see 2 rows, so this represents row 1, and each particular element in a list represents a column. So we had the column like ID, sensor, location. Similarly we have the ID, sensor and location, all these columns available over here. So all the rows is now splitted, and each row represents different columns for that particular row. Now to fetch the element from this particular row, I can use the similar concept that we use in a list. So in a list, if I want the first element, you can see that type is str and list 0. When I do, it will give me the first element of the list. So if I run something like this, it will give me the first element, and since it is of a type string, we can apply it over here. Let's apply some transformation to do some analysis on the data. So if I want to count the number of sensors, what I can do over here, I can see which particular column the sensor is. We see that the second column is the sensor ID. So if I want to count the number of sensors, what I can do a distinct function, because there would be multiple occurrence of the sensor. So there is a distinct function available in RDD. What we are going to do, we are first going to fetch the first element, which is a sensor ID, using the map function. So this will pick up the first element of this particular list, and once I do the distinct, it will drop all the duplicate occurrence of the sensor ID. And with the help of take 5, we are going to see how those element looks like. So if I do the distinct.take5, you can see that these are the sensor ID available, and it is clearly visible on the data set as well. So we have 2266, 2292. Similarly, we have multiple sensor ID available. So using the map function and then distinct and then take 5 gives me the sample. If I want to count those sensors, I can apply the count function. So once we apply the count function on this particular data set, we can see that there's 56 distinct sensor ID available in the data set. If I want to collect, I can perform the collect operation here as well. So it will only give me the 56 records because we have given distinct sensor ID over here. So you can see that we have the 56 sensor ID available as an output. If I want to collect this particular sensor ID to a list, you can just set the variable and you can assign the output to this particular variable called a sensor. So if you see over here, once we apply the collect and store it in a variable, all the sensors are now available in the sensor variable. If to take a sample, you can use 0 to 10 slicing, and you can see this is how sensor ID looks like. Now if I want to know how many number of records are available for a sensor 2266, I can apply a filter operation. So syntax of filter is similar to what we have seen in map. You just have to pass on the condition over here. So lambda row, which means that it will take each row as an input, and for each row, since the first element is the sensor ID, it is going to compare that if that particular sensor ID belongs to 2266. So if I do a count, it will give me the count of the sensor ID 2266. And if I want to see how it looks like, I can use a take 5, and this take 5 will give me the rows for those sensor IDs with the ID 2266. We have already seen how to create a PairRDD. You can use a tuple, like in the case of word count. We can see that we have a row available and we can assign anything to that row. So in this particular case, I want to create a paired RDD. In the paired RDD, I want the first element to be the sensor ID and the value should be the complete row. Instead of assigning 1 as the example of word count, we are over here going to assign the complete row as a value to this particular paired RDD. So paired RDD means that we want to create an RDD of key value pair. So if I perform this and if I do a take 1, you can see that the key is the sensor ID and the value over here is the complete row. Now let's move ahead and see how we can count the number of records for each sensor. Over here we had to filter one sensor, but since there are 56 sensors, you won't be able to do that one by one because it would be a very tedious process. So in RDD we have a function called as CountByKey which can be used. So if I do a CountByKey, it will apply the count on each of the keys. So we have multiple keys as a sensor ID, and it will provide me the output as a dictionary. So you can see for sensor ID 2266, we have the 17708 records. Similarly, for all the sensor ID, we can get the number of records using the CountByKey operation. Now let's move ahead with the other functions that is available. You have the union function available. In the union function, if I want to union multiple RDDs, you can use the union function. So let's say we have RDD1 with the name and age. Similarly, RDD2 and RDD3 and RDD4. So let me create these RDDs. And if I want to do the union, I can do RDD1.union RDD2. Similarly, you can create a chain and apply the union to all of the RDDs. And if you want to see the result, you can see that RDD1 looks like this, where we have Phoebe, Monica and Rachel. Similarly, we have the RDD2 and once we see the RDD union, you will see that all the elements of these RDDs are now available in one RDD. So this is how RDD union works. There is a join function also available in the RDD. You can create a employee and department RDDs over here, and if I want to join the these two RDDs, you can do RDD employee dot join RDD department. So if I do this and do a dot collect, you will see a different output of join in RDDs as compared to data frames or any SQL join. Over here you can see that there is a key available as 1. You can see that all the values that belongs to a particular key is grouped together. So key 1, we have Williams and HR. You can see that in the output there is one key available as over here, and the values is Williams and HR. So William is of HR department. So this is how RDD join works. There is a Cartesian join also available in the RDD, which means that each row of one RDD is going to get joined with the each row of the different RDD. So if you see, we have the order and product RDD. In the order RDD we have O1 and O2, and in the product RDD we have face wash, hand wash and body wash. If I do a Cartesian product on this particular RDD, you will see that each of the element in the RDD1 is now joined with the each of the element in RDD2. So we have 6 output. For O1 we have 3 records, again for O2 we have 3 records. We can also do the caching of the RDD. So let's say, as an example, you have done a complex transformation and that transformation took a lot of time for the computation purpose. Now if you want to use the result again somewhere, you don't want to perform the operation again. So instead, if we have the intermediate result available, we can persist that result in memory. For that, RDD.persist function is available. In the persist function, you can pass on the storage level, which has a memory only, which has memory and disk. There are multiple options available over here. So in the memory only persist level, all the data will be fitted into the memory. So let's say if you want to cache a huge result which you can not fit into memory, you can use the memory and disk, which means that all the data that is available, it will first try to fit into the memory, and if there is a spill, it will store rest of the result into the disk. So if I do a RDD.persist, and then once we do the RDD.count, first action is required to compute the result and store it in the memory. It took some time to compute, and if I do it again, you can see that the time taken by calculating the count of RDD, since we have already persisted it, every time we are now going to use this particular RDD, once it is persisted, it will be very fast because we don't have to do any computation. Once we have done the persisting, and once we have applied all the transformation, if we don't want that particular result, we can use the RDD.unpersist. This will remove the RDD from the memory. Let's move ahead and see another function in an RDD, which is a ReduceByKey. ReduceByKey basically is used whenever we want to perform any aggregation like sum, min, max, count. So let's use ReduceByKey for this particular question. I want to find the average pressure per sensor per day. So to calculate this, I want to use ReduceByKey, because ReduceByKey first do the local aggregations and then only it shuffles the data from one node to another, hence helping us in optimizing the transformation. If we look into the data set, we have 9 elements, 9 columns available, from starting from sensor ID till humidity, and we are interested in the pressure. So pressure stands as 0, 1, 2, 3, 4, 5 and 6. So it is the 6th element starting from 0. So we are going to use this particular element to calculate the average pressure. So to calculate the average pressure, we are first going to remove the rows with the columns less than 9. So there are some data quality issues in the data set available as well, where we don't have the complete information of the data set. So instead of 9 columns, we have in some data set, we only have say 6 rows or 7 rows or 5 rows, which means that we don't have the sufficient rows to calculate the pressure. So there may be a possibility that some column in between pressure and the first column are missing, which means that the pressure column might have some other value that we do not want. So it might have the temperature value in the place of pressure. So to remove that, we are first going to remove the rows which has less number of columns, and we are going to only apply the operation on the complete rows. And we are also going to remove the rows where pressure value is not defined, which means that we are going to remove the null values. Once that is done, we are going to again create a key value pair, and with the sensor ID and timestamp as the key part and the value as pressure and 1. Objective behind grouping the sensor ID and timestamp was because we want to calculate per day average pressure. That's why we are going to group the date column as well with the sensor ID. So let's first see how the RDD looks like. So you can see over here that we have the RDD available in the form of the splitted rows. Now to apply the average pressure, we are first going to filter the rows which don't have the length 9, which means that we are only going to take the rows with length 9. Similarly, if the pressure is not available in the 6th column, which means that if there is a null value available, we are going to filter that out. And finally, we are going to apply the PairRDD formula, where we are going to have key as sensor ID, and there is a date column available, so we are going to group it with the help of sensor ID and date. And in the value, we are going to have the pressure, and we are going to have the 1. I'll explain why we are going to have 1 as a value part. So once I execute this, you can now see that we have the key as sensor and date, and the value as the pressure and the 1. So reason of adding 1 over here is when we apply the average function, we say that we want to do the sum of observations upon number of observations. So if I take the example of a sensor ID 2266 for a date 1st of July 2017, I'll take all the occurrence of this particular sensor, and we are going to count it using 1, and we are going to sum the number of occurrence of the pressure. So number of observations would be sum of this particular 1, and the total observations, that is sum of pressure, will be this particular value. So average is sum of observation upon the number of observations. So same formula we have applied in the ReduceByKey. You can see over here that I have used ReduceByKey, and as I have explained earlier that ReduceByKey is x comma y, which means that it takes first 2 rows, it will do the sum, and then it will go to the another row. So in the ReduceByKey, we are first going to take the 2 rows. So taking an example, we are going to take the first row for this particular group, and similarly we are going to take the second row. We are going to sum the pressure as well as we are going to sum the 1. So if you see over here, we have x0 plus y0, which means that pressure from the first row and second row, and x1 plus y1 means that 1 value from the first row and the second row. Once we apply this to all the records, we will have the aggregated view of all the sensors for a particular day. So you can see that for sensor 2292, we have the total pressure as this, and number of occurrence was 577, and this is for 1st July of 2017. So we have the sum of observations as well as number of observations available. Now to calculate the average pressure, we first want to do the division of sum of observation upon number of observation. In this particular scenario, we can use it with the map function. In the map function, we are going to pass on the result of ReduceByKey, where we have calculated the sum of pressure and the number of observations, and we are going to do the division. So if we see over here, we already have the ReduceByKey applied. So this is a key, so this is a x0 in this example, and this whole thing is a x1. So what I did over here, I did a map lambda x. In the x0 we have the key, which is date and sensor ID. In the value, that is x1, we are going to take the first element, which is this. X1 of 0 is pressure, sum of pressure, and x1 of 1 is the number of occurrence for that particular sensor. So this particular formula will give me the average. So once I apply this, you can see that we have the average pressure value available for each date for a given sensor. This is how you can apply the reduce by key operation